Hello, welcome to section 8.4, where we're going to be adding, subtracting, and multiplying radical expressions. So what are like radicals? We need to define that first. So like radicals are, roots that have exactly the same thing, inside the radical. Okay, so let's say, for example, you have cube root of 4x. Then a like radical would be like, 5 cube root of 4x. Notice that it's exactly the same. And what's cool about that is when you get used to it, adding and subtracting like radicals is just like how you would add and subtract variables, right? You simply ignore the variable and you add the coefficients or subtract the coefficients. So let's say, for example, here you have 2 square root of 2 plus 7 minus 7 square root of 2. So that's going to be negative 5 square root of 2. Okay, so you have, I just want to highlight so you can see 5 of these plus 4 of these, right? 4 squared of y, cube root of y, that just gives you 9 cube root of y. Okay, so 9 of these. You see what I'm saying? That's kind of the way that we need to think about it. 7 fourth root of x minus 2 fourth root of y. Oh, tricky. These are not like terms. So you have this kind, and this one would be a purple or whatever, pink. So that's it. We can't combine. So not like terms. This is as far as we go with that. Okay, how about here? 2 5 root of n, 5 root square root of 5n minus 6 square root of 5n. That's negative 4 square root of 5n. Oh, wait, crap. Sorry. I forgot this. Plus 4 square root of 5n. So then that just ends up being 0 because negative 4 plus 4. Negative 4 plus 4 is equal to 0. 0, 5 root of n, which is just 0. Anything, 0 times anything is 0. Okay, so now here, this is 1, 3x, fourth root of 3xy plus 5 minus 4. So in other words, we just look at the numbers. So 1 plus 5 is 6, minus 4 is 2, and then whatever the radical was. It was fourth root of 3xy. Okay. Okay, so sometimes, but it's not always given to you that nicely, right? Sometimes we have to reduce a little bit or simplify the radical a little bit to see if they are in common. So here we have square root of 20. Square root of 20 is square root of 4 times 5, which itself is 2 square root of 5. Now bring the rest down, plus 3 square root of 5. Final answer, 5 square root of 5. How about this? Cube root of 24, that's cube root of 8 times 3 minus cube root of 375 is 125 times 3 as well. So cube root of 8 is 2. Cube root of 3 minus cube root of 125 is 5 because 5 cubed is 125. So that's 5 cube root of 3. So now these are the same. So your final answer, negative 3 cube root of 3. It's a lot of 3's. Okay, so then half, and then 48 can be written as 16 times 3 minus 2/3. 243 is 81 times 3. Okay, so fourth root of 16 is 2. So 1/2 times 2 fourth root of 3 minus 2/3. Fourth root of 81 is 3. So 3 fourth root of 3. So cancels, you just get 1 minus 2, because after the canceling, you get 1 fourth root of 3 minus 2 fourth root of 3. So then negative fourth root of 3. All right. Wait, oops. So here, let's simplify and then see if we can, what we can factor out and what we can't, okay? So here it's 9. 50 square root of 50 is 25 times 2 times m squared minus 6. And then 48, the perfect square in there is 16. 16 times 3 m squared. So then this simplifies to become 9 times 5 because it's square root of 25 is 5. Oh, and then the m squared cancels out. Sorry. So then that becomes m. And then what's left is just square root of 2 minus, then you have the 6. Square root of 16 is 4. Then you have this m squared that becomes m, and that's cube root of 3. So 45m square root of 2 minus 24m square root of 3. We cannot combine these because they're different radicals, so we leave it as is. Okay, next here, cube root of 54n to the power 5. So let's write this, that's friendly for cube roots. That's 54 is 27 times 2. Remember our perfect cubes, right? N to the power 5 can be rewritten as n squared times n to the third power minus cube root. 16 can be written as 8 times 2 and n to the 5 n cubed times n squared. So let's take out the perfect cubes. This becomes 3n on the outside. And then what's left on the inside, cube root of 2n squared minus, okay, let's take out the perfect cubes. That's 2n cube root of 2n squared. So combining, now this this part here is exactly the same as this part, right? So we can combine like terms. 3 minus 2 is 1 today. So your final answer is n cube root of 2n squared. Remember that there's always a 1. It's just we don't write it every time. So if you see nothing in front of the coefficient, as for the coefficient, if you see nothing in front of the variable, that means that there's a 1 there. Okay, so product property is the next thing we want to talk about. Product property is that when you multiply two radicals together, that's the same as taking the root of the product. So let's just see some of this into action, right? So it can go both ways. It can be split up or it can be condensed. So the way that we should think about this, you don't have to commute every single time, right? But I'll just do it this one time. Commutative property says since this is all multiplication, I can think of it as 3 times 2 times square root of 2 times square root of 10. 6 times 3, sorry. 6 times 3 is 18 today. Whoa, what the? 18 square root of 2 times square root of 10 is 2 times 10, which is 20. So 18 square root of 20, but we can reduce 20 to 4 times 5. So square root of 4 times 5. Square root of 4 becomes 2, so you get 18 times 2. And in the radical is 5, so 36 square root of 5. Okay, let's do another one. Again, you don't have to do a couple of steps. You could have skipped maybe the first few steps, but that's fine. So here, negative 5 times negative 4. We can write 20 cube root of 4 times 6, which is 24. So 20 cube root of 24. But 24 is 8 times 3, because that's our cube. So 8 times 3. We factored it in a different way. So cube root of 8 is 20. So 2. So 20 times 2 cube root of 3. And then that's 40 cube root of 3. And that's our final answer. Okay. A few more. So this is going to be you take the, multiply the coefficients because of commutative property. Square root, what's inside, you have 18p to the power 4, because there's 3 here and there's 1 here. So square root of that, 18 is 9 times 2. Square root of 9 times 2, p to the 4th power. Square root of 9 is 3 today. Square root of p to the power 4, using the rational expression, the rational exponents property, that's just 4 divided by 2, yeah? So 4 divided by 2, so you get here on the outside 40 times 3 times p squared, square root of what's left is just 2. So 120 p squared root 2. Okay, let's do the next one. Let's multiply these. 6 4th root of, then you have 20 times 28. So let's see. So if I factor, let's just multiply it out first, I guess. Fine. That's going to be what, 560? Yeah. There's an easier way to do this, and I know it. I can almost taste it, but I can't. So y squared, y cubed, that's when you multiply them, you add the exponents, y to the power 5. I'm thinking, what if we take 560 and we divide it by, let's see, what could be the largest fourth root, right? It has to be fourth root. So maybe 16, because that will give you 35. So fourth root of 16 times 35 times y to the fourth times y. Why did I split that up? Y, because it's a fourth root. So fourth root of 16 is 2, so 6 times 2 on the outside. Oh, and then y to the fourth, that cancels out, so that's a y there. What's left is 35y on the inside of the radical. So that's 12y, fourth root of 35y. Okay, let's do a few more. So here we have, we're distributing a radical. So this is going to be square root of 12 plus square root of 6 times 18, which is 7, nope, just kidding. 6 times 18 is 108. What's going on with my brain today? This must be my chickens. Okay, 108, square root of 108. What are the perfect squares here? So 12 can be written as 4 times 3. 108 divided by 3 is 36. This is a plus sign. I don't know why it's acting weird. Hold on. Give me a second. Plus. Okay, this is a 0, by the way. 36 times 3. I'm looking for perfect squares so that I can factor them out. Remember this property, right? I'm using it all the time now, but I'm not writing it out because I'm assuming that you guys know that it's existing. So that's 2 cube root of 3 plus, I'm sorry, this is 36. 6 cube root of 3, so that's 8 cube root of 3. I mean square root. Sorry, I don't know why I'm saying square cube root. Hello. Oh, my Lanta. Okay, so here we're distributing, and this one is not a cube root, so we're going to write that as 5 cube root of 9. Okay, minus cube root of 9 times 18. Okay, now let's try it another way. Let's see if we can factor in such a way that we get a cube. So this is 3 and 6. This is 3 and 3. Look, we have 3 3s here, so that's good. So 5 cube root of 9 minus root 3 cube root of 3 times 6. Okay, so again, how did I get to here from here? I factored each term. Since they're being multiplied, this is the same way. I just did prime factorization, okay? So 5 cube root of 9 minus the 3 comes out of the house, and what's left is a 6. These are not like terms, so we leave as is, okay? Then I want to do an example for you where we're multiplying a 2 by 2. So let's see here. We can use box method for this, or you can use FOIL, whatever floats your boat. You can use FOIL, you can use box method. So you write the first one, 3 square root of 2 minus square root of 5. Square root of 2 plus 4 square root of 5. Now multiply inside the boxes. This is going to be 3 times square root of 2 squared. That's just going to be 3 times 2, which is 6. Here, you're going to get negative square root of 10. Here, on the upper right box, you're going to get 12 square root of 10. And in the bottom, you're going to get negative 4 square root of 25, which is just 4 times 5. Negative 4 times 5, which is negative 20. So combining like terms, 6 minus 20 is negative 14. Negative root 10 plus 12 root 10 gives me 11 root 10, and I'm done. So not too bad. Of course, it helps to remember your special products. Remember, when you have a binomial squared, the product is the same as the first term squared plus twice the product of the two terms plus the last term squared, or the second term squared. Okay, so what does that mean here? So here I have a binomial. So using special products, this is going to be 2 squared plus 2 times root 3 plus root 3 squared. So this is going to be 4 plus 4 root 3 plus 3. So 4 plus 3 is 7 today, plus 4 root 3. Okay, next We have here the binomial. It's a perfect square trinomial. It's going to be. So 4 squared minus 2 times 4 times 2 root 5. 2 root 5 plus 2 root 5 squared. That's going to be 16, excuse me, minus 16 root 5 plus, now this is 2 squared times 5, right? Because 2 square root of 5 squared is like 2 square root of 5 times 2 square root of 5. So that becomes 4 square root of 5 squared, which is just 4 times 5. 16 minus 16 root 5 plus 20. So that becomes 36 minus 16 root 5. Okay, and then let's do this last one is difference of squares. Difference of squares. If you have two binomials, you know, where it's a plus b, a minus b, you can multiply them, and that becomes a squared minus b squared. So then we get 5 squared minus, and then b here is 2 root 3 squared. So 25 minus, and then that's going to be 4 times root 3 squared, so that's going to cancel out. So then you're going to get 25 minus 12, final answer 13. So that's it for this section. Here's your super fun homework. Good luck, and I will see you in the next video.